Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so today we are going to continue with a discussion with chapter 4, matrices, the first lecture for this topic. And as you see the screen here now, we are going to look into the topic of matrices and system of linear equation. Okay, so I do hope that all of you get ready with your lecture notes in your hand. Without wasting so much time, let's continue. Okay, so for this topic, at the end of this discussion, the student should be able to identify the different types of matrices, okay, and perform operation of matrices and find the transpose of a matrix. Okay, so a matrix is a rectangular array of numbers enclosed between brackets. So the general form of matrix with m rows, okay, m. So according to this one here, row number 1, row number 2, row number 3 until row m. And then with n columns, we got column number 1, column 2, column 3 until we call the final one is column of n. Okay, so m and n can be any numbers or any size. And here is n columns. So the number that makes up a matrix are called entries or elements Aij, where I indicates the row and J indicates the column. So for example here, so look at this one. For element of 3, it's stated, we call situated in the row number 1, row 1 and column 2. So look at this one here now. The element of 3 is A with with 1 as a row number 1 and column number 2. So look at the 8 here now. 8 situated in the row number 2 and column number 1. Okay, row number 2 and column 2 here. So the order or dimension of a matrix with m rows and n column is m times n. For example, we have this example of matrices with row 1 and row 2 with one column. Okay, column 1. So it's stated as a m and n, which is in order of 2 times 1, m times n, where 2 rows and 1 column. And this one here now, we have row 1 and row 2, and we have column 1 and column 2. So in the orders of size of 2 times 2. So type of matrices, row matrices is a 1 times n matrix 1 row. Okay, that's example then. So example with A, which have we call in 1 row, there's a column 1 and column 2. Okay, there's only 1 row here. Okay, and also the size of 1 times 4, one row with 4 column. So column matrix is m times 1 with 1 column. For example here, okay, 0, negative 4, and what we have here is row 1, okay, row 1, 2, 3, and 4 with only 1 column. So it is 4 times 1. Square matrix is a n times n matrix which has the same numbers of rows and column. So you can see here now, this is row 1 and row 2, and here is column 1 and column 2 with the orders of 2 times 2. And here also we got 3 times 3 matrix. So 0 matrix is a m times n matrix, which is every entry is 0 and denoted by capital letters of or might be a big zero then, for example, here and here. So doesn't matter about the size. The only thing here is every entry 1, 2, 3, 4, 5, 6 it all zeros, and also here 1, 2, 3, 4 with all zeros. So diagonal matrix is a square matrix where all elements are zero except those in leading diagonal. Okay, so diagonal matrix is a square. Okay, square matrix where all the elements are zeros. So look at this one here, 1, 2, all the zeros here. Okay, except those in leading diagonal. Leading diagonal means that here. Okay, so these the element of these are not zero except, which I think that we can say, the upper triangle here and the lower triangle is all zero. So diagonal entries of A are A11, A22 until AMN. Okay. So for example, we have this one here, the diagonal 2 and 3, which is non-zero. The rest is all zeros, and all here. Okay, and this one here, 1, 2, and 3 are the element which is non-zero. So okay, identity matrix is a diagonal matrix where all diagonal entries are 1 and denoted by the capital letter of I. So the first one then, example here, the identity matrix of 2 times 2, where you can see here, we call a 0 here, and the entries of this is 1. Okay, and also here, we call there's a lower triangle with a 0 and the upper triangle with all the zeros. So we call diagonal here with entries of 1, 1, and 1. So lower triangle matrix is a square matrix, and the element of Aij equal to 0 here. A lower triangle matrix is a square matrix for A where I less than J here. This is a element, this is a position of 1, 1. Okay, 2, 1, 3, 1. So you can see here, there's a upper triangle with 0, and the rest of entries here are non-zeros. Okay, so the lower triangle matrix. Okay. An upper triangle matrix is a square matrix where the lowest triangle here with entries of 0, and on the top here is where all the non-zeros element or numbers there. Okay, operational matrices, we can make addition and subtraction of the matrices. Only defined when, okay, so addition or subtraction of two matrices is only defined when they have the same order. The same order means that the same size between, for example, if I have a matrix of A and matrix of B, it is M times N. Okay, the same order, for example. Okay, so what we have here right now is a matrix of 2 times 2 and 2 times 2. So find A plus B. Okay, so first one here with A plus B, which is 1, 2, 3, 4, plus with B 4, 3, negative 5, and 6. Okay, so you can come up with, okay, 1 plus 4, 1 plus 4, 2 plus 3, 3 plus negative 5, and 4 plus 6. And finally, we get the answers here. 1 plus 4 equal to 5, positive times negative is negative. 3 minus 5 equal to negative 2. 2 plus 3 equal to 5. 4 plus 6 equal to 10. Okay. Sorry. Okay. So for B, a matrix of B minus A. B minus A. B minus A. So we list down the matrix of B first, which is 4, 3, negative 5, and 6. 4, 3, negative 5, and 6. Minus matrix of A, 1, 2, 3, 4. So 4 minus 1. 4 minus 1. 3 minus 2. Negative 5 minus 3. Negative 5 minus 3. 6 minus 4. So 4 minus 1 equal to 3. 3 minus 2 equal to 1. Negative 5 minus 3, negative 8. 6 minus 4 equal to 2. Okay. Okay. Never mind. I made the solution earlier, just now. So leave it there. Okay, scalar multiplication. If a C is a scalar or any value, okay, and multiplied with the matrix of A, then CA, as you see in the screen here now, we call the scalar of C multiplied with every element inside the matrix of A. So, for example, we have here, okay, so this one will come up with 3A, which is 1, 2, 3, 4, minus 2B, 4, 3, negative 5, 6. Okay. Okay, never mind. I'll make the show this solution next slide. Okay, there you go. So just imagine that 3 multiplied with every element inside this come up with 3 times 1 equal to 3, 3 times 2 equal to 6, 3 times 3 equal to 9, 3 times 4 equal to 12, minus 2 times 4 equal to an 8, 2 times 3 equal to 6, negative 2 times negative 5. Okay, because we have minus here, leave it outside. So just imagine that it's just 2 times negative 5, negative 10, and 2 times 6 equal to 12. Okay. So then 3 minus 8. 3 minus 8, negative 5. 6 minus 6 equal to 0. 9 minus negative 10. So 9 negative become positive. So 9 plus 10 equal to 19. And 12 minus 12 equal to 0. Okay, next. Properties of matrices. Okay, so matrix of A plus B equal to matrix of B plus A. Okay, for addition and subtraction, as long as the size or the order are equal between A and B, and A plus B in bracket plus C equal to A plus in bracket B plus C with the associative properties here, and then A minus negative A or negative A plus A equal to 0, and any because scalar of alpha plus beta multiplied with an A matrix of A equal to scalar alpha times matrix of A plus beta multiplied with matrix of A. And as you see screen here now, I just read it for all of you, or you may just read by yourself. We're going to look from example, which is more easier then. So the product of two matrices A and B is defined only when number of columns in A is equal to the number of rows in B. So if order of A is m times n and the order of B is n times p, okay, then the AB multiplication of matrices of A and B has an order of m multiplied with p. So then if the matrix of A is m times n and we call the order of matrix of B is n times p. Okay, so the column of the first matrices of A, let's say A and B, the column of matrix of A equal to the we call row of matrix B. When these two are equal, then we will get the matrix of AB with the order of m multiplied with p. Okay, so the first thing before we get the matrices with the orders of m times p, make sure that the column of the first row here, the column of the first matrices of A equal with the row of the matrices of B. Multiplication between these two. Okay. And A times B, matrix of A times B is not equal to matrix of B times A. Okay, so that's it. The thing that I mentioned to all of you just now, make sure that the column of the first matrix equal to the row of the other matrix before we can multiply between these two matrices of A and B. This number must be equal. And m times p is the order of the product of AB, the result. Okay. So multiplication of two matrices, this one here. Okay. So we call one row 1 times n, and this one is n times 1. Okay. Example 3. So this is a matrix of 1 row and 3 column. So 1 times 3. And this is a matrix of 3 rows and 1 column. So multiplication of AB A times B with 1 times 3 and 3 times 1. So the row of matrix of A equal to the column of matrix A is equal to the row of matrix B. They are equal, so we can simply find the value, multiply between these two, and we will get the result of matrix of A times B with a size of 1 times 1, which I think that it will going to give you 1 value. Okay, for example here, 2, 5, 1 multiplied with 0, 3, 2. Okay, the first one, 2 multiplied with 0. Okay. Oh, sorry. Okay, so it is 2 multiplied with 0 plus 5 multiplied with 3, 5 times 3, plus with 1 multiplied with 2, 1 multiplied with 2. So it give you 2 times 0 equal to 0, plus 5 times 3 equal to 15, plus 1 times 2 equal to 2. So it give you one matrix with one value, which is 17. So it's a matrix of 1 times 1 with one value only, 1 entries. And look at this one here now. This is a matrix of 3 times 3 and also 3 times 3. So the column of first matrices of A equal to the row of matrix of B. So we can, once these two are equal, then we will get the matrix of AB with a size of 3 times 3 here. Okay. So now class, let's I'll show you the step of this one by one. First, we're gonna focusing on the entries or element in row number 1 with column number 1. So the first thing is it is -1 multiplied with 2 plus with 2 multiplied with 3 and 1 multiplied with 1. So that is the first one. Okay. Then next, we're still focusing on element in row number 1, -1 to 1. But right now, we're gonna make a multiplication and operation between row number 1 and column number 2. So now, again, -1 multiplied with -1 plus with -1, again, 2, these 2 here, multiply with these 2 and 1 multiply with 4. Okay, I think that I need to make some adjustment here because there's no lack of space here. Okay, sorry, never mind. I'll do it again. Sorry, it's all correct, but then because there's a lack of space here, so I rewrite this. Okay, the first one is we're focusing on the entries in row number 1 and column number 1. So -1 multiplied with 2, -1 multiplied with 2 plus with 2 multiplied with 3, 2 and 3 plus with 1 with 1. So 1 with 1. Okay. Now, we're focusing on entries again in row number 1 of matrix of A, but right now we are making operation with the entries in column 2. So again now, -1 multiplied with -1 plus with 2 with 2 and then plus with 1 with 4. 1 multiplied with 4. Okay. And next is still entries in row number 1 of matrix of A, but right now we look in being make operation between this and the entries in column 3 of matrix of P. So the first one is -1 multiplied with 2. -1 multiplied with 2. Then 2 with 1. And 1 with -1. There you go. Okay, so guys, girls, at this moment we already complete multiplied or make an operation between element in row number 1 with column 1 here, row number 1 with column 2 here, and row number 1 with column 3 here. So now we're going to move to the element in row number 2. Okay, so row number 2, what we have here right now is 3, 4, and 5. So then let's make operation between row number 2 with column 1. So first is 3 multiplied with 2 plus 4 multiplied with 3 plus with 5 multiplied with 1. Okay, so next, with row number 2 with column 2. So the first is 3 multiplied with negative 1. 3 times negative 1. Then 4 with 2. 4 with 2. And plus 5 with 4. 5 times 4. Okay. Next. Yet we still focusing on the we call the element in row 2 for matrix of A here, and we are going to make operation or multiply with the entries in row 3. So 3 times 2 plus with 4 times 1 4 times 1 plus with 5 times negative 1 plus 5 times negative 1. Okay, actually it is negative 1 here, sorry. Okay, so now class, we are complete make operation of entries in matrix of A in row 2. So then we move to the element or array entries in row 3 of matrix A, one by one with column 1, column 2, and column 2. We repeat the process. So now is between row 3 with column 1 here. So 2 times 2 plus with 3 times 3 and 1 times 1. Okay. And now we're focusing on element in matrix of A, row 3 with matrix of B in row number 2. 2 times negative 1 plus with 3 times 2 plus with 1 multiplied with 4. Okay. And then it's time now for element in row 3 of matrix A with column 3 of matrix B. So first with 2 multiplied with 2, 2 times 2, then 3 times 1, 3 times 1, and 1 multiplied with negative 1 plus with 1 times negative 1. Okay. So now we are going to add all of this. For example, negative 1 times 2 is negative 2. 2 times 3 equal to 6. 1 times 1 equal to 1. So 6 plus 1 equal to 7 minus 2 equal to 5. Negative 1 times negative 1 is 1. 2 times 2 equal to 4. 1 times 4 equal to 4. 4 plus 4 equal to 8. Plus 1 equal to 9. 2 times negative 1 is negative 2. 2 times 1 equal to 2. 1 times negative 1 is negative 1. Negative 2 plus 2 equal to 0 minus 1. It is negative 1 here. Okay. 3 times 2 equal to 6. 4 times 3 equal to 12. 5 times 1 equal to 5. 6 plus 12 equal to 18 plus 5, 23. Okay. 3 times negative 1 equal to negative 3. 4 times 2 equal to an 8. 5 times 4 equal to 20. 20 plus 8 is 28 minus 3, 25. 3 times 2 equal to 6. 4 times 1 equal to 4. 5 times negative 1 equal to negative 5. 6 plus 4 equal to 10 minus 5 equal to 5. Okay, now 2 times 2 equal to 4. 3 times 3 equal to 9. 1 times 1 equal to 1, 4. 9 times 9 plus 1 equal to 10 plus 4, 14. Okay, this is negative 2, 6, 4. 4 plus 6 equal to 10 minus 2, 8. And 2 times 2 equal to 4. 3 times 1 equal to 3. 1 times negative 1 equal to negative 1. 4 plus 3 equal to 7 minus 1 equal to 6. So this is the matrix of A times B. And the result is also a matrix of 3 times 3. Okay. So class, I do hope that all of you know how to multiply between these two matrices of 3 times 3 with 3 times 3 here, slowly one by one row with entries of multiplication of every row with every entries on every column here. Okay. So transpose matrix of A written as A transpose is a matrix obtained by interchanging the rows and column of A. That is the I column of AT and the ith row of A for all i's. Okay, so example here now, if B is a matrix of 3 times 1, row 1, row 2, and row 3 with column 1, one column only, so then B transpose is it become 2, 1, 3. So interchange of row and column, it will become 1 times 3. Then so for D, as you see on the screen here now, then D transpose equal to every entries on the row will turn into column, and the entries of column will turn into row. So means that this is row number 1, it become column number 1, 1, 3, 3. Row number 2 then become column 2, 2, 5, 4. And row number 3, 1, 3, 5, and become column 3, which is 1, 3, 5. That's it. So if A and B, find A minus B transpose. Okay, earlier we know that we call operation between A matrix of A and B, addition or subtraction, they must come in same size. Okay, but what we have here right now is a matrix of 1, 2, 3, size of 3 times 2 column, so 3 times 2, and here now is a matrix of 2 rows and 3 column. So we cannot make an operation between these two. But then, because from this question, A minus B transpose, so B transpose is an interchanging between the rows and columns. So right now it's a matrix of 2 times 3, where 2 rows and 3 column. It become now, okay, matrix of 3 times 2. Okay, so first row 2, 5, 3 will become first column 2, 5, 3, and second row will become second column of 3, 2, 4. Now we can make operation between these two because the size is 3 times 2 and also 3 times 2 here. So A minus B transpose equal to 2, 5, 4, 3, 1, negative 1, minus Okay, 2, 3, 5, 2, 3, 4. So now 2 minus 2 equal to 0. 5 minus 3 equal to 2. 4 minus 5, negative 1. 3 minus 2 equal to 1. 1, 1 minus 3, negative 2. Negative 1 minus 4, negative 5. There you go. Okay. Properties of transpose. Okay. A transpose, we change it, then we go between the row and the column of the matrix of A, and we transpose for the second time. It will give you back the matrix of A. Okay, and then for A plus minus B in bracket, okay, make an operation of addition or subtraction of A and B first, and then once we transpose, then we call the result of this is also equal to the A transpose plus minus B transpose. And when the scalar of K multiplied with the L matrix of A, then we transpose it equal to K, the scalar of K multiplied with the A transpose. Okay, and also A multiplied with B first. If we multiply A and B first, then we transpose the result. It will be also equal to B transpose multiplied with A transpose. So please be careful with this. Okay, sometimes we might think that it is A transpose times B transpose. No. Okay, so please remember this. So example 7, let B and C then verify that C transpose equal to C transpose then. Okay, so now if I solve the one on the left side first, let's find out B times C first. A matrix of B multiplied with C. Okay, 3, 4, 2, 1. Multiplied with 1, 4, 3, 2. Okay, so 3 times 1 equal to 3, plus with 4 times 3 equal to 12. 3 times 4 equal to 12 plus 4 times 2 equal to 8. 2 times 1 equal to 2 plus with 1 times 3 equal to 3. 2 times 4 equal to 8. 1 times 2 equal to 2. Okay, so 12 plus 3, 15. 2 plus 3 equal to 5. 12 plus 8, 20. 8 plus 2 equal to 10. So now this is B multiplied with C. So transpose the result of this B, C transpose. Then now it become, the row is 15 and 20. It become column now 15 and 20. And then row 2, 5 and 10 become second column 5 and 10. Okay, so this is the first result of this on the left side here. So let's try with this one here now. Okay, I make a line to divide it into two parts here now. Okay, so C transpose, we have C 1, 4, 3, 2. Then C transpose multiplied with B transpose. Then now become 1, 4, 3, 2 of 1, 4, 3, 2. Wait, is this? Yes, BC and transpose with C transpose B transpose. So B transpose 3, 4, 2, 1. Again, 1, 4 and 3, 2. Okay, so now 1 multiplied with 3 equal to 3 plus, okay, 1 multiplied with 3 and 3 times 4 equal to 12. and then 1 multiplied with 2 equal to 2 plus 3 times 1 equal to 3. 4 times 3 equal to 12 plus with 2 times 4 equal to 8. Then 4 times 2 equal to an 8 plus 2 times 1 equal to 2. Okay, so let's see the result of this. 3 plus 12 equal to 15. 2 plus 3 equal to 5. 12 plus 8, 20. 8 plus 2 equal to 10. So you see the result of this. Now they are equal. Then we can make a conclusion that BC transpose equal to CT multiplied with B transpose. Okay, get it? Yeah. Okay, so conclusion of this for the first lecture of this one here, the first lecture of this topic. So we look into the type of matrices with the row, column. We get to know with the row, column, square, diagonal, zero, identity, we call lower triangle and upper triangle. Okay, and the operation of addition, subtraction, or multiplication. So class, look at this. The operation of matrices, we have addition, subtraction, multiplication. But do we have division here? Nope. Okay, there's no division, just like, well, let's say we have x equal, okay, 2x equal to 4, then we divide by 2 left and right, x equal to 2. Okay, but this is not going to happen in the topic of matrices. Okay, please be careful. There is no division between matrix and matrix, just like we learned in some other topics. And then we also learn about transpose here. Okay, that's all. Thank you very much. Till we meet again with the next series of lecture. Thank you. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.